Welcome. So what I'd like to do is show you how to be able to solve a quadratic formula. Just kind of some basic ideas, not anything very specific, but just kind of in general, what are some different ways that we look at solving a quadratic? So the first thing we need to understand is what exactly is a quadratic equation or function if we had to solve one. So when we talked about linear equation, we looked at the standard form as well as the slope-intercept form. And a quadratic, we can look at the same thing. Y equals ax squared plus bx plus c. You could also look at a vertex form. Why not? Y equals x or a times x minus h squared plus k. These are two examples if we were going to look into graphing them that you can see they are quadratics. And the main important thing that tells us they're quadratics is you can see my x is going to be squared. Rather than linear equations where my x had a power of 1, now my x has a power of 2. So when we're looking into solving, there's a couple different ways that we look at it. The first way is what we call our inverse operations. All right. The next way is our factoring. And the last one is our formula. So depending on the form.
Mr. Holloway, please call the main office. Mr. Holloway, please call the main office.
OK. So depending on what the form is of your quadratic, we can go ahead and apply different operations. For instance, if I have a quadratic that's in the form of y equals ax squared, I can solve for x, let's say even like this, by what we call applying the square root property. So when using inverse operations, that's pretty much saying that we only have one variable, but it's squared. So we're going to want to solve this by using the square root property. Oh, I did put 2 zeros there, or 2 O's. And the square root property, pretty much all that basically says is, using your inverse operations, just like linear equations, undo addition and subtraction first, undo multiplication and division second. But then there's that powers, or exponents. Well, how do we undo that? Well, that's taking the square root. So hence, that's why the square root property comes in. But that only works when we have a quadratic, for instance, that is either in this format or is in y equals a times x minus h squared plus k format. So we can only apply the square root property when it is in these two formats. And we could also get any quadratic, like in standard form, to vertex form by completing the square. So if you want to solve a quadratic and it is in y equals ax squared, and actually you can have plus c, sorry. If you have it in that format where there's only one x and a squared, you can apply the square root property. Or if you have a quadratic in this format, vertex form, or you transform it into vertex form by completing the square, you can also use the square root property, or commonly used as our inverse operations, to solve. The other formats is y equals ax squared plus bx, and y equals ax squared plus bx plus c, and y equals ax squared plus c. We can also go ahead and solve these by factoring techniques. And the common factoring techniques that we look at is there's kind of regular factoring, which would be kind of considered as like our GCF, like just factoring out a GCF to help us factor it further. So for instance, I could if I had a format like in here, I would want to factor out the GCF, which would be x, and then I could go ahead and solve. Factor out the GCF, and then if it's in this format, we can look at trinomials. So factor in a trinomial when a is equal to 1, and also a trinomial when a is not equal to 1. And the process that we use is like the diamond method, and finding the two numbers that multiply to give you your constant, but then add or subtract to give you your middle term. And so that's the whole practice factoring. But what's also important about factoring is we also have our special products. And to look at our special products, we have a perfect square, as well as the difference of two squares. So when we're looking at factoring, the first thing I always like to say is, determine what type of format is it in. If it's in this format, I would look into factoring by the GCF. If it's in this format, the first thing I would do is look into factoring via a perfect square. If it's not a perfect square, determine is a equal to 1 or is a not equal to 1, and then factor it. And if it's in this format, I would obviously look into see, can I solve this by using the difference of two squares? If you can't solve it using the difference of two squares, then you can go back and use the square root property to go ahead and solve. The main important thing about factoring, which is so important, factoring gets us somewhere, but if you don't understand the zero product property, then why we use factoring doesn't really make any sense. So when we're solving quadratics with inverse operations, it doesn't really matter. You're just using your inverse operations. However, when we're factoring, the idea of factoring is to take an expression and rewrite it as a product of two other expressions where it's exactly the same. So therefore, when we're factoring, we've got to make sure that our product is equal to 0. So when you're solving a quadratic, and if you have to apply the factoring technique, you got to make sure it's set equal to 0, because then our two expressions, and here I just have two variables, a times b, but it could be 0 equals x minus a times x plus b. You got to get your product equal to 0, so therefore we can apply the zero product property, which would then tell us that x minus a equals 0 or x plus b equals 0. And the last one is going to be our quadratic formula. And again, very similar to factoring, when we're looking into the quadratic formula, we can solve using quadratic formula when in any form of a quadratic. We want to make sure we have it in standard form. And again, our standard form, ax squared plus bx plus c, we want to set it equal to 0. Because the most important thing about solving the quadratic formula is not only knowing the formula, which is x equals opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2a, but also knowing what does a equal, what does b equal, and what does c equal. And so to find those exact values, we've got to make sure our quadratic is, again, set equal to 0 to have those correct processes. So I know this is a lot to kind of take in, ladies and gentlemen, but I just wanted to kind of give you an overview of how we solve quadratics. Thanks. Hello.